Today we're going to talk about polygons. A polygon is a plane figure with straight sides. That just means that it's flat, closed, and straight. So polygons are named by the number of sides that they have. And if you have a three-sided polygon, we all know that that is called a triangle. A four-sided polygon is known as quadrilateral. A five-sided polygon is called a pentagon. A flat closed shape that has six sides is called a hexagon. A seven-sided polygon is a septagon. An eight-sided polygon is an octagon. A nine-sided polygon is a nonagon. And a 10-sided polygon we call decagon. Two other terms that you should be familiar with when we're talking about polygons are parallel and perpendicular. Parallel is when two lines never intersect. They always are the same distance apart. And the symbol for parallel is two lines, one next to the other, but not touching, an equal distance apart. Perpendicular means that lines meet or intersect, forming 90-degree angles. And the symbol for perpendicular looks like this. Two lines intersecting or meeting, forming 90 degrees. Let's take a look at triangles. So triangles can be identified based on two different things: the measure of their angles or the length of their sides. Let's start by looking at the measure of their angles. If a triangle has one angle that has a right angle or forms 90 degrees, then it is known as a right triangle. One angle is 90 degrees. If a triangle has three angles that are less than 90 degrees, then we're looking at an acute triangle. There's no obtuse angles, there's no right angles, there's simply three angles that are less than 90 degrees. An obtuse triangle then has one angle that is greater than 90 degrees. And we can see right here that this angle is greater than 90 degrees. So all triangles have 180 degrees. So this triangle, if we looked at the measure of all three of their angles, this right triangle would have a measurement of 180 degrees. This acute triangle, also the sum of the measures of the angles would be 180 degrees. And the obtuse triangle, all triangles have a total sum of 180 degrees if you add their three angle measurements together. Now, if we look at the length of the sides, we can see that they can have different names based on the fact of how long they are. So in our scalene triangle, we'll see that all side lengths are different. All the side lengths are different. So this side is not congruent to this side, which is not congruent to this side. And we show that by using these tick marks on the side, that none of them are the same. 1 is not the same as 2, which is not the same as 3. So scalene triangles have no side lengths the same. For an isosceles triangle, two side lengths are congruent, and therefore two angles will be congruent. So in this isosceles triangle, the length of this side is equal to the length of this side. These are congruent. And that will cause these two angles down here to also be congruent. And an equilateral triangle, as I'm sure you know, tells us that all side lengths and angles are congruent. All of the side lengths and angles. So the measure of this angle must be the measure of this angle, must be the measure of this angle. And this side length is congruent to this side length, is congruent to this side length. Now, if the sum of the measures of the angles of every triangle equals 180 degrees, then we know for sure that an equilateral triangle must have 60-degree angles, because 180 degrees divided by the 3 angles means each angle would be 60 degrees. So every triangle can be classified as 2 different triangles. If we look at this triangle in the middle, we'll see that it has 2 side lengths the same, and that all of the angles are less than 90 degrees. So this triangle is an isosceles triangle and an acute triangle. So we would say that this is an acute isosceles triangle. All right, let's move on to quadrilaterals. Quadrilaterals is what we would call any and all 4-sided polygons, but we can get more specific about the type of quadrilateral we're looking at. So quadrilaterals are a 4-sided polygon. And if I were going to draw a quadrilateral that could only be identified as a quadrilateral, no sides could be congruent. So this side, or parallel, this side could not be parallel to this side, and this side could not be parallel to this side. When that happens, the only name that you can give this shape is quadrilateral. Okay? So one of 2 things can happen when we're looking at quadrilaterals. If you have one pair of parallel sides, if this side is parallel to this side, but the top and the bottom are not parallel, then this name is trapezoid. A trapezoid has only one pair of parallel sides. But if you have 2 pairs of parallel sides, which means the top and the bottom are parallel and congruent, the sides are parallel and congruent, then we're looking at a parallelogram. Now, our parallelogram shows that the top and the bottom and the sides are congruent to each other. And so it has 2 pairs of parallel sides. The opposite angles are also congruent. So this angle is congruent to this angle, and this angle is congruent to this angle. Okay? But there's no right angles. If we actually took our parallelogram and we gave it 4 right angles, our parallelogram would become a rectangle. So our rectangle still has 2 pair of parallel sides. This is parallel and congruent. This side is parallel and congruent, right? But it also has 4 right angles. So a rectangle is actually a parallelogram with 4 right angles. Now, if we called this shape here a rectangle, you would be correct. If you called this shape here a parallelogram, you would also be correct. And if you called this shape here, this rectangle, a quadrilateral, you would still be correct, because quadrilaterals are 4-sided polygons. A parallelogram has 2 pair of parallel sides, but a rectangle has more. He has 4 right angles. Now, if we go back to parallelogram and we take our shape and we give it 4 congruent sides, this side is still parallel and congruent to this side, but we're going to make the sides also parallel and congruent to these sides. So we have opposite sides are parallel and congruent, but all sides are congruent. When this happens, you form a rhombus. Now, a rhombus not only has all sides congruent, but it has opposite angles congruent. All angles are not congruent, but all sides are congruent. So this angle is congruent to this angle, but this angle here, he's congruent to this angle up here. Okay? And in this shape, the diagonals will form 90 degrees. And we haven't seen that yet in any of our other shapes. So if we draw diagonals from corner to corner, this will actually form 90-degree angles in the middle. That was not true in our rectangle and parallelogram. All right, so if we were looking at a rhombus, could we call it a parallelogram and be correct? Yes, because it still has two pairs of parallel sides that are opposite and congruent. It just has more. It has four congruent sides. Could we call a rhombus a rectangle? No, because a rectangle has four right angles. Could we call a rhombus a quadrilateral? Yes, because it's a four-sided polygon. Now, if we take a parallelogram that has opposite sides parallel and congruent, two pairs of parallel sides opposite and congruent, and we throw in right angles like a rectangle, and we throw in four congruent sides like a rhombus, we would end up with a square. A square is a rhombus and a rectangle combined. It's a parallelogram because it has opposite sides parallel and congruent, but it also has four congruent sides like a rhombus, and it has four right angles like a rectangle. So when we look at the diagonals of a square, we'll see that they also form right angles.